Game of Thrones Part 1. Real-world science can explain how it could be possible for a spherical planet orbiting a single star to have seasons like ours, but for their duration to be unpredictable. The world of Game of Thrones doesn't have a name in the books, but has come to be called Planetos by fans because of Westeros and Essos. So let's use the name Planetos. Type of planet. First, we need to consider what tidally locked means. Our moon is tidally locked to our planet Earth. As our moon makes one rotation around us, it rotates only once on its own axis, meaning one side of the moon is always facing towards us on Earth, and the other side is always facing away. A planet tidally locked to its sun does the same thing as our moon. It has one side permanently facing its sun, therefore scorched and dry, and the other side facing away in permanent freezing darkness. A ribbon planet is tidally locked to its sun. Isaac Asimov realised that, in theory, there could be a relatively narrow habitable band around a tidally locked planet, and he called this a ribbon world. Planetos is a ribbon world. Among the exoplanets we've discovered so far, we don't know of any real-world examples yet. But they could exist, and Planetos, being a ribbon world, would explain so much, which is why this video is only part 1 of many. Orientation. The map of Game of Thrones has been assumed to lay in a similar way to our own northern hemisphere. On a ribbon world, the map could be anywhere on the ribbon. What the characters refer to as the north means going in the direction of the entire enormous side of the planet that's in perpetual freezing darkness, and going south means travelling towards the burning side. So, not the same as our north and south. More science on that later. Light and dark, or day and night. On a ribbon world, the habitable ribbon is in perpetual half-light, neither day nor night, always twilight, like dawn and dusk. And in the world of Game of Thrones, there are clearly days and nights. There is a solution to this. Despite the story taking place in a society with roughly medieval levels of technology, the story could be taking place thousands of years in the future. If human beings, us, discovered the ribbon world Planetos, they might decide it would be a fantastic place for an experiment, or even a game. They'd have 2 main choices for the perpetual twilight issue. Solution 1. Genetically modify humans to not mind. But our circadian rhythms are quite deeply baked into our existence. Even simple organisms have a form of sleep. The resulting humans might be so different culturally that they would seem barely human. And anyway, solution 2 is cooler. Solution 2. Construct a Dyson swarm, not a Dyson sphere, around the sun of Planetos. It reflects sunlight towards the ribbon to create an artificial day, and reflects sunlight away from the ribbon to create an artificial night. The metal bands in the opening sequence of the TV series represent the reality around their sun. The images on the band represent important events from Planetos' history and in the final season they're updated to show important events of the previous 7 seasons. There's a fandom page that explains this, link in the description, and more on this later. Size. By placing the map of Game of Thrones onto what must necessarily be a relatively thin ribbon, Planetos must be larger than Earth. Our study of exoplanets is in its infancy, but we do know that rocky planets such as ours can have almost twice the diameter of ours. That makes for a seriously bigger planet. The gravity will be much higher. There's some wiggle room because planet density varies, but Planetos is clearly rocky and has volcanoes, so let's not go into planet density too much. Since humans by this point are comfortably a Kardashev level 2 civilization, they wouldn't have any problem genetically modifying or selectively breeding people to be shorter, to be more comfortable in the higher gravity. Or maybe just kidnapping people that have already evolved to be shorter on high gravity planets elsewhere. More on these humans and their shorter humans and morality in part 2. Indigenous plant species. Considering Planetos' plants supports this theory further. East of Ashai, there's the Shadowlands, which are, as their name suggests, always in shadow. The Shadowlands exist because the Dyson swarm doesn't bother with that bit. The ghost grass that grows there is an indigenous plant species that in the perpetual half-light has evolved an alternative photosynthesis pathway not using chlorophyll. No other plants can grow there because the light is too weak to compete via chlorophyll photosynthesis. The weirwood trees are native too, with their red leaves and sap and wood that doesn't decay. On Earth, in our Carboniferous period, there's a theory that our trees were not biodegraded because the fungi or microbes to break down lignin hadn't evolved yet, and that's why we have coal deposits. Most of the other plant and animal species mentioned in the books have been introduced by humans from Earth, which is why they resemble ours so much. More on indigenous species in part 3. Variable season length. This is what you're here for, but first we need some science about our planet Earth and then compare it to Planetos. Earth science. Earth has the Coriolis effect in our atmosphere. Our atmosphere swirls around in unpredictable circles, responsible for hurricane season in North America. Earth has a molten core, and in this molten core, there's also a Coriolis effect. The molten iron swirling around is the source of our magnetic north and magnetic south poles. Magnetic north and south are not the same as true north and true south. True north and true south are the points that define our axis of rotation. Earth rotates on its true north-south axis once every 24 hours, creating day and night as we orbit our sun. This axis of rotation does not change as we orbit our sun, but two things do change. One change is the angle of Earth towards our sun. Summer in the northern hemisphere is when the angle tilts so that the north is facing more towards the sun. At the same time, the southern hemisphere tilts away from the sun, making it winter. The other change is the exact position of magnetic north and south. They move around a little because they're created by Coriolis currents in our molten core, which move unpredictably, like underground hurricanes. There's a great video that explains this well and includes why the system of airport runway numbers in Canada are different to everywhere else. Link in the description. Planetos science. Planetos must have a molten core because it has volcanoes in Valyria, and the map shows continental drift, with Westeros previously having been connected to Essos. Its molten core has a Coriolis effect, creating unpredictable magnetic north and south poles. Its bigger size might make its Coriolis effect stronger. Only rotating once per year might make its Coriolis effect weaker. Still, overall, unpredictable magnetic north and south poles. As a ribbon planet, its angle of rotation around its sun does not change. Otherwise, the ribbon would be unstable, just as our tidally locked moon does not change its angle of rotation around our world. Unpredictable season length. Naturally, on Planetos, there would be no seasons at all, just the stable ribbon in perpetual twilight. But its unpredictable north and south magnetic poles interact with the metal in the Dyson swarm around its sun. This causes tiny but unpredictable variations in its angle of rotation. Planetos' summer is when their part of the ribbon is tilted towards the tidally locked hot side, and their winter is when they're tilted towards the cold side. Note that because the planet has tilted only slightly, it won't make any difference to the length of day and night, as that is controlled by the Dyson swarm. So there you go. But this part 1 video is going to answer 2 more important questions. Like and subscribe would be nice. This channel is new and a solo creator that never uses AI. Remaining question 1. The Maesters announce when winter is coming. The length of day and night stay the same. So how do the Maesters know? It's so easy. They measure a sustained decrease in the maximum height of the sun in the sky. Their tall tower in Old Town might be used for this. All you have to do is measure the length of the shortest shadow around noon. But to maintain their power and mystique, they choose not to reveal this simple knowledge that anyone could use. It's like Eratosthenes' calculation of the Earth's circumference in 240 BCE. There's a good video that debunks flat Earth using Eratosthenes' method. Link in the description. So the Maesters probably also know that their planet is enormous. Remaining question 2. Everyone knows what a year is. Here on Earth, a year is obvious by the seasons in temperate climates, but even at the equator, where the seasons exist but are less obvious, people know a year because of equinoxes. On Planetos, everyone refers to years, and there's no suggestion that the Maesters declare when it's a new year. Everyone just knows. Here on Earth, we can also tell the passage of a year in the northern and southern hemispheres because the stars change their positions, but it's quite subtle and requires studying the stars. So how do the people on Planetos just know? It's easy because their planet is tidally locked to its sun. It's even easier if their position in the galaxy is more towards the edge than ours. We're in a spiral arm, but it's not required. But let's assume it is to make explaining it easier. A planetosphere is still one revolution around their sun, like us, but their nighttime view of the stars is quite different. For half of the year, at nighttime, they can see zero or very few stars in the sky because they're looking away from the galaxy. For the other half of the year, at nighttime, they can see their galactic disk in the sky. There will just be a convention to decide when a new year starts, as we have decided for us. Most likely when a bright star in the galactic disk is first seen again after the half year of dark skies. Or if the planet is not as far from the galactic disk, it still works. After one revolution around the sun, a star that was last seen a year ago will reappear. There's so much more to come. The various religions, what magic is, giants, the children of the forest, White Walkers, why Daenerys is only sometimes fireproof, why Westeros implodes against itself, Quay's messages to Daenerys, and more. Every subscribe really means something to a new channel. I'm a solo creator. My videos on Agatha Christie's Towards Zero are voiced by someone else because I didn't have the confidence to do it myself at that point. Hope to see you in part 2.